Hey, welcome back! Today I'm breaking down how to prepare two super important gases in chemistry: carbon dioxide, also known as carbon-4 oxide and carbon monoxide, or carbon-2 oxide. Whether you're prepping for your KCSE or just curious about how these gases work, let's dive in. Let's start with carbon dioxide, CO₂. In the lab, you'll need dilute hydrochloric acid and some solid calcium carbonate, think chalk or limestone. The acid drips onto the carbonate and you'll see fizzing as CO₂ gas bubbles out. But before you collect it, the gas gets washed through distilled water to scrub out any sneaky hydrochloric acid, then dried using concentrated sulfuric acid. Why? Because CO₂ must be pure and dry for most tests. We collect the gas by letting it push air upward. It's heavier than air, so it easily sinks. To test if you've actually made CO₂, pass it through calcium hydroxide solution or lime water. If it turns cloudy with a white precipitate, you've nailed it. CO₂ isn't just lab trivia, it's used in fire extinguishers, soda drinks, and even baking. That crackly texture in cakes or mandazi, that's CO₂ from baking powder, making your dough rise. Now, for carbon monoxide, Colorado, this one's trickier and a lot more dangerous. You heat methanoic acid with concentrated sulfuric acid, which acts as a dehydrating agent. The reaction gives you carbon monoxide gas and water. But beware, CO is called the silent killer because it's colorless, odorless, and super toxic. Always ensure good ventilation and don't sniff around. CO is useful industrially, in making chemicals like methanol, and as a reducing agent in metallurgy. But in real life you definitely want to avoid breathing it in. How do you tell CO₂ and CO apart? Easy. Bubble both gases through lime water. CO₂ gives a white precipitate. CO does nothing. Remember, always know your safety rules, your chemical equations, and the real-life uses for what you learn. If this helped, hit subscribe and turn on notifications. I've got more science essentials coming.
If your aluminium foil turns white when exposed to gas, you're witnessing real chemistry magic. Curious how? Stick around. Hey everyone, welcome back to KC Channel Schooly, your go-to spot for KCSE chemistry tips. Today, let's break down the classic reaction between hydrogen chloride gas and aluminium foil, an experiment that shows just how cool chemistry can get. So here's the setup. We start with potassium chloride and concentrated sulfuric acid. When these two mix, they produce hydrogen chloride gas, HCl for short. But before we use that gas, we dry it by passing it through anhydrous calcium chloride. Why? Because moisture can mess with our results. A glass wool plug is added to keep outside moisture out, and a screen protects the rear stopper in the apparatus. All set? Now, the dry HCl gas is sent over aluminium foil. Here's the fun part. As the HCl gas reacts with the foil, a white sublimate forms. That's aluminium chloride, and it's special because it sublimes, going straight from solid to gas and back to solid, without becoming a liquid. That's why you see it as a white solid on the foil. If there's any moisture around, aluminium chloride turns into aluminium hydroxide and hydrochloric acid. That's why drying the gas is crucial. And there you have it, a quick, classic chemistry demo. Want more? Hit subscribe and never miss a lesson.